Okay, so here's the key. I already started working on it, and so the first little bit is just going to be explaining, I guess, how I did it. And so for 2A, right, graph, it says to graph the solution set. Okay. So I don't know if the wording threw you off a little bit. I can't really make this work, I guess, with my camera, but it does say graph the solution set for the system of inequalities, determine a solution, check its validity, describe the solution region, right? So we're just going to graph this. That's basically what they're asking us to do. And then we're going to determine whether or not these points are actually part of the solution or in the solution region. So I guess one thing that you don't need to worry about describing the solution region, but determine a solution that we certainly can do. Okay, so let's go ahead and look through these questions. Right, so I'm going to try to, so note that because it's a system, I'm using reverse shading. The first inequality is just a vertical line that goes through 6. So it's a solid line. The true region will be to the left. We shade to the right because we're doing reverse shading. And then the second inequality is exactly how I want it. I proceed to find my x-intercept, y-intercept. Note that, right, it's negative x equals to 6. And so I have to divide both sides by -1 to get this. And so I get my x-intercept, y-intercept. I go ahead and rewrite it, and I get this. It's also dashed, or this one is dashed. True is below, right? And so I shade above. With all that information, I go ahead and plot it. Notice that my scale is 2. I'm going up by 2, 2, 4, 6. And so I graph my vertical line, which is solid. The diagonal line is dashed. This one I shade above. This one I shade to the right. So my solution region is right here. I label my lines. Everything is there. The point of intersection, right? You type both of these into your calculator and find the intersection. And so that this is the point of intersection, but it's not a solution. Why not? Because right here where they meet, right, a point that's on this line is not part of the solution, right? But actually right where they meet, right where they meet here, it would be, because at this point you're on that solid line as well, which makes it part of the solution region. So 6, 4 would actually be part of the solution. But what is a solution, right? A solution could be, you could pick 4, -4, right? It would be right here. So a solution would be 4, -4. You could also pick, you know, -2, -8, and so forth. So there's lots of options there, or possible solutions, that is, right? And this could be just etc., right? Anything in the solution region will do. And then for B, it's asking us for various points and to check whether or not they would indeed be part of the solution. So what I do is I plug in, right, noting that this is x and this is y. At the x is less than or equal to 6, right? It's just, right, in this case x is 6, so is 6 less than or equal to 6? And the answer is yes. The equal part works out in this case. It's not less than, but it is equal to. So it's either or. If one of those is true, then the whole thing is true. And then we plug in x and y into the second inequality. I always go back to the original, meaning this one, right? And then I plug it in, and I get 6 is less than 6. That is not true, therefore it's not part of the solution. And I repeat that, right? For the second point, right off the bat, it's not true. So I don't even bother checking for the second one. It's just not in the solution region. I tried 3, 2. It works for the first one. It also works for the second one, so it is in the solution region. And you can just look at it, right? 3, 2. This would be 3, and this is 2, so it'd be right there. right? So it is graphically and algebraically. 3, 3, I plug them both in. It works for the first one. It does not work for the second one, so it's not part of the solution. So this is how you would show the work, but you could also just go right 3, 3 would probably be in the shaded, which is the false region in our case. Okay. For 4, I started graphing already, so I have both inequalities there. When it's just x, y, no other coefficient and a number, x and y intercepts are easy. I rewrite it. I tell myself that it's solid, true is below, shade above. The second inequality is just a horizontal line. Horizontal, right? Y is a number. Through 0, 2, it's dashed, true is above, shade below. I go ahead and graph them, right? My horizontal line here, and x and y, right? I label all that. It's a solid diagonal, shade above, shade below, solution region is right there. And does the question say give a solution, determine a solution for each? So yes, so I still want you to always find the point of intersection. In this case, the point of intersection would also be a solution because it happens to be on the solid line, right? And the dash crosses it, but the solid line makes it part of the solution. If both of them had been dashed, then this would not have been part of the solution. Okay, so possible solution. You can state, right? Let's go out here. It's a scale of 1, so -2 and 3. Okay, and the list goes on. You could go -10, right, and 3 if you wanted. Anything like that would do, as long as it's not in the shaded region. And it cannot be simply on this line. So if you went -2, 2, that would be right on the dashed line, so that would not work. You could go -2, 2.1, like as soon as you're a little bit above, then you're okay. Right? For B, I've graphed it here already. So the first one looks like that. And notice that, right, it's going to be 0, 0, 0, 0, no surprise there. But this one doesn't have, right, you got to be careful. This is not where x is equal, has a 1, a coefficient of 1 in front of it. It's 2. So I still go through the motions, right, but 2x equal to 0, if you divide both of them by 2, you still get x equal to 0. So this is one of those cases where you're going to have to find a second point. And so why? I just rewrite that one. Bring the 2x over negative, it's dashed, true is above, shade below, and I just grab a random number. Okay, so I will say that this is random, but you want it to make sense and not to be too big of a number. You could have picked 1, but let x equals 3, and then basically if x is equal to 3, if you go back to this one, right, if x is equal to 3, you just go -2 times 3, that's what happens here. Y is -6. So you for a moment forget about the inequality and just look at the boundary line. And so basically when x is equal to 3, y is equal to -6. So that's my second point that I'm going to use to connect, right? And the same thing here. This one, I bring the x over for a little bit, 0, 0, 0, 0 again. So that doesn't really help us. I bring the x back over to the other side. This is dash, true is above, shade below. I'm going to let x equal to 1, and y is also going to be equal to 1. So I'm going back to this one, right? If x is equal to 1, if you plug that in here, y is also going to be equal to 1. So that's my second point. And so we go to the origin. For this one, we go to the origin, and then 3, -6 is right there. So I use the origin and that one and make a dashed line this way. And for the other one, it's 0, 0 and 1, 1, right? So 1, 1 is right there. and I use that to make my line. That's a dashed line. Both of them I have to shade below, right? And my solution region is right there. The point of intersection happens to be 0, 0, because we know that it goes, both of them go through it. That would not be part of the solution because both of them are dashed. So possible solution could be 0, 0, 2, anything like that, right? 0, 2 or 2, 10, right, etc. Right? Anything that isn't in the shaded part. Okay, so that's 4B. Let's try 4C here. And I'm just writing it, I'm copying it off of the book. We have 3y minus 2x. 3y minus 2x is less than or equal to 6. And I'm going to put the other one next to it. 2y minus 3x is less than or equal to 6. And this one, I don't know if you paid attention, x is part of the real or natural numbers in this case. We don't worry about that. We just graph it the way I've shown you. Okay, so both of them are the exact same format that I would like it to be in. You don't have to always write x-intercept, y-intercept, but it does help. So then it's negative 2x is equal to 6. Divide both sides by negative 2. X is equal to negative 3, right? 6 divided by negative 3, 0. Make sure you don't flip them, okay? And then the y-intercept, I'm just going to focus it one more time here. There we go. And then the y-intercept is 3y is equal to 6. Divide both sides by 3. Y is equal to 2, so it's 0, 2, okay? I rewrite that. So it's 3y is less than or equal to 2x positive plus 6. Divide both sides by 3. That's what I get. So this is important to me. Solid, true is below, shade above, all good there. Do the same thing here. I'm just going to do this, okay, like a t-chart. So it's negative 3x is equal to 6. Divide both sides by negative 3. X is equal to negative 2, so negative 2 is 0. Over on the other side, I have 2y is equal to 6. Divide both sides by 2. Y is equal to 3. So that's 0, 3. So very important not to mix things up because they kind of look alike, right? Numbers kind of look alike, so we're not going to make the mistake. And then it's 2y is less than or equal to 3x plus 6. Divide both sides by 2. Y is less than or equal to 3 over 2. X plus 3. Important to me. Solid as well. True is below, shade above. Okay. I make note here, both of my intercepts, the y-intercepts match the slope-intercept form, and now I'm ready to graph. Okay. If I can find my ruler, here it is. Okay, x and y. I don't need to go too far out. Okay, so I'm gonna go 1, 2, 3, 4, 5, negative 5. 5 here. 1, 2, 3, negative 5. That's 5. So 5 in each direction. X and y is labeled, and now we can graph. So negative 3, 0 is there. 0, 2 is there. It's going to go up from left to right, and my slope is positive, so we're good to go. It's going to be a solid line. So there we go. I'm going to label this one. And then the other one is -2, 0, 0, 3. So that one is also solid, and it goes like this. It has a steeper slope, right? It rises more than it runs. So it's steeper and it's positive. The slope is positive, so also going up. And both of them I'm shading above, so you got to be careful here. Use your ruler and shade this one above. And then use the other one and shade that one above also. It's a bit of an overlap, right? And so your solution region is this wedge here, right? This is your solution region. And point of intersection, which I want you to find. Graphing calculator, and now is time to enter that. So you have 2/3 x plus 2, 3/2 x plus 3. Graph it. See if it looks like what we have, and it does, right? So second trace 5, enter, enter, enter. And so it's -1.2, 1.2. And it would be part of the solution because both of them are solid. You only need one of them to be solid for it to be part of the solution. But the point of intersection is kind of a separate thing. And possible solutions. You could have, you know, 2, -2, let's do 2, -3, so we don't repeat. Okay, go 5, 1, right? 5, 1, you'd definitely be in, etc. So that's that. So now we need to do D. D is y minus x is greater than or equal to 3. And then we have y plus 2 is less than or equal to x. Okay, both of them have two variables. Both of them are going to be diagonal. And this one is how we want it. You have to be careful here because of the sign. Okay, the sign is going to be very careful. So if it's y plus x, no problem. If it's negative, you have to kind of, right? X-intercept, y-intercept. And so it's going to be -x is equal to 3. Divide both by -1, right? And so that gives you a -3. So -3, 0. And on the other side is y equals to 3, so it's just 0, 3. So that one, you have to watch your signs. It makes a big difference. The graph looks completely different, right? So y is greater than or equal to x plus 3, right? The x comes over adding. I'm not going to box it in necessarily anymore. So true, solid. True is above, shade below. Okay. Then the other one. I'm going to bring the x over. Y minus x is less than or equal to 2. And then so x-intercept, y-intercept. Sorry, x-intercept, y-intercept. There we go. And so we have -x is equal to 2, divide both by -1, x is equal to -2, -2, 0. And on the other side, y is equal to 2, so it's 0, 2. Okay, and then we write it y is less than or equal to x plus 2. Oh, I made a mistake. I wonder if you caught it. I brought the x over, the 2 comes over negative. Back to the drawing board. That means that this is negative, So yes, you still have to divide both sides by -1, but this gives you a +2. So +2, 0. And on the other side, y is equal to -2. So it's 0, -2. Good thing we caught it. So, right? So because if I go back here, the -2 is negative when it comes over. The 2 is negative when it comes over, sorry. To say that, I'm just going to double check. Yeah, I wrote it down correctly. So here we go. It's a solid line. True lies below the line. Therefore, we're going to shade above. And they're very small numbers, so we don't have to go too crazy with our graph. Just going to keep it smaller there. X, Y. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3. Try to space it out equally. Okay. And then -3, 0, 0, 3. It's a little bit, you know what? That's why we have an eraser, right? We can adjust, no problem. Solid, y greater than x plus 3. And then the other line is 2, 0, 0, -2. And this one is interesting. They're parallel lines. I don't know if you remember that. They both have the same slope, 1 and 1. Okay. If lines have the same slope, they're parallel, they will never meet. But let's see what we do here. This line here, I use the original way of the true region is below, so we shade above, and the other one we shade below. So what's happening here? This one we shade below. So this one, in fact, will have no solution region. Because if you think about it, everything is going to be false. No solution region. Everything is shaded. All right. And that also assigned 5. So I'm going to go to 5 here for each system. Graph the solution set, describe the solution region, not necessary. Determine a solution, check its validity. So we're supposed to check if it's valid. Okay, so let's give that a try, shall we? So I'm looking at my time here. I don't know if I'm going to make the whole video, but at least you'll have enough to go off of. So this is question 5. Let's do I. And here we have the inequalities. So x plus y is greater than 5. And the other one is y is less than or equal to 4. Fairly easy to do, right? If it's x plus y, it's just 5, 0, 0, 5. I'm not going to make a big deal out of it. Horizontal, right? Horizontal line through 0, 4. It's going along across the y-axis, right? I'll just rewrite this. And so this one is this one is dashed, true is above, shade below. This one is solid, true region is below, shade above. And so one, two, three, 4, 5. Five each way. And so we have 5, 0, 0, 5. It's a dashed line. X plus y is greater than 5. And here we have the line 0, 4, which is a solid line. We're shading above that one. And we're shading below this one. It's all predetermined. The whole thing, everything is gone below it, right? So your solution region is here. We're going to find a POI. So we have negative x plus 5, and then 4 is y. Horizontal line, second trace 5, enter, something 4, right? 1, 4, no surprise. 1, 4 would be a solution. It is a solution, right? 1, 4 is a solution. Let's check. Plug it in. So x plus y is greater than 5. Oh, sorry, is greater than. Oh, did I get this wrong here? So 5 is greater than 5. That is not true. So this is false. So you technically are done there. And 4 is less than or equal to 4. We don't need to do this, but that would hold water. So therefore, not a solution. I'm going to have to clarify this tomorrow then. So I guess if both of them have to be solid for the solution, for the corner point or the point of intersection to be considered a solution. Both of them have to be solid. Okay, now you heard it. If you do your homework, you know something that I haven't clarified yet in class. So the second one, let's try that one. Let's see if we can manage to get that in here. So we have, I'm going to cut this here. X plus y is greater than or equal to 1. And the other one is 2 is greater than x minus 2y. Okay. So this is 1, 0, 0, 1. Because there is x plus y, and you have that there. So let's rewrite it. Y is greater than or equal to negative x plus 1. This is going to be a solid. True is above. We're going to shade below. Then this one I'm going to rewrite. You can rewrite it or just write this over on this side. Right? What should I do? I will rewrite it and see if you get the same as me. So the x is over negative, the 2y comes over positive is greater than negative 2. Okay? So we find our x-intercepts and our y-intercepts. X-intercept would be negative x is equal to negative 2, divide both by negative 1. X is equal to 2, so 2, 0. And we have 2y is equal to negative 2, divide both sides by 2, y is equal to negative 1, so 0, negative 1. Right? I box that in, I rewrite 2y is greater than x minus 2. Divide everything by 2. Y is greater than 1/2 x minus 1, which jives. Good to go. So this is a dashed line. True is above, shade below. And I'm going to have to do the graph on a separate piece of paper. Right, so graph on the back side of this. I'm just going to 0, 1. Yeah, it's not a big grid that I'm going to make. So 1, 2, 3, 4, 5. Negative 3. Positive 3. Okay. So then we have our points is 1, 0, 0 and 0, 1. I'm just checking. The next one looks like it's going to be more interesting. 1, 0 and 0, 1. And it's solid. And this is the line x plus y, right, is greater than or equal to 1. And the other line, I had 2, 0, and 0, negative 1. 2, 0, and 0, negative 1. Was that a solid? No, that's a dashed line. And I'm going to use the 2 is greater than x minus 2y. I think I said that both of them need to be shaded below. Yeah. So let's go ahead and do that. If I focus on this one, I'm shading below here. If I look at this line, I'm shading below here. Everything below it is gone. So this is my solution region. Point of intersection. Negative x plus 1. And the other one is 1/2. I'm going to have to check one more time. Short-term memory. Minus 1. Okay, and it does look like it's connecting in a similar area than I have, right? So second trace 5, enter, enter, enter. So it's 1.33, negative 0.33. So this one isn't as pretty, right? And again, this one would not be part of the solution. Possible solution would be, you could do 2, 3. Right? So 2, 3, you're way up here. You're definitely in the solution region. You're supposed to check its validity. So we would have to do that, right? So with the first one, I'm just going to go 2 plus 3 is greater than or equal to 1. 5 is greater than or equal to 1. That holds water. The other one, it says 2 is greater than x minus 2 times 3. Is 2 greater than 2 minus, this is 6, right? 2 is greater than negative 4, and that is true. So this point that I chose, I checked its validity by plugging in into all the inequalities present and making sure that at the end they're both true. All right, 5 II, triple I, that is. Let's write them down here. This one will be interesting. Or not, we'll see. 2x minus 6 is less than or equal to 3y. Okay, this one is how I want it. So x-intercept, y-intercept. So that would be 4x is equal to 44. And what do you know? That is going to be a nice round number, but it's bigger, right? 11. The other one is 11y is equal to 44. What do you know? That is also a nice round number. Also, like at first it's going to be like that. Later on it changes. So then it's 11y is greater than negative 4x plus 44. Divide both sides by 11. Y is greater than negative 4x, or negative 4 over 11x plus 4. True is, sorry, this is dashed. True is above, shade below. So the next one, I will rewrite it. I'll go 2x minus 3y is less than or equal to, the 6 comes over adding. The 3y came over subtracting. So 2x is equal to 6. X is equal to 3. So 3, 0 is that. Negative 3y is equal to 6 divided both sides by negative 3. Y is equal to negative 2, 0, negative 2. Smaller, but then you have your 11, 0 there, right? So you need to make sure we account for that. I'll rewrite here. Negative 3y is less than or equal to, I'm using this one, negative 2x plus 6. Divide everything by negative 3. Oh, dividing by negatives. Flip the sign. Negative divided by negative is positive. Positive divided by negative is negative. Okay. Important to me. Solid. True is above. That the true region is really, that doesn't change, right? Shading is below. We're just shading the false region to make it easier. So I'm going to focus a little bit more on the positive side of x and try to fit this graph in. Might have to erase, but that's okay. So I'm going to go up by 2s, right? 2, 4, 6, 8, 10, 12, right? So 2, 4, 6, 8, 10, 12. So that's the way it goes there. So I have to stick with that here on along the x, but here I can change to 1 again. 1, 2, 3, 4, 5. So it's -5. 1, 2, 3, 4, 5. Sorry, I meant to put it there. So it's 5 and 5. And then I'm just figuring out my scale here. So this will be 11, 0, because this is 10, right? 11 is there. And 0, 4 is right there. And that's a dashed line. Just like that. And this is y is greater than -4/11x plus 4. And the other one is 3, 0, which is right there. 0, -2, solid line. Graph that. Y is greater than or equal to 2/3 x minus 3. All right. Let's shade. So we're supposed to shade below for our first line, which is this one. Okay. And the other one says shade below as well. So both of them are below, both of them have the inequality pointing the same way. So let's go. There, so this is your solution region. Let's figure out the point of intersection. So we have -4/11, right? That's an interesting slope. X plus 4, and the other one is 2/3. X minus 3. There's my first line. And then I'm not seeing the x-intercept of the first line because it's 11, right? I have a standard window right now, but I'm not interested in that. I'm interested in the point of intersection. So as long as you can see it, that is good. So we have 6.79, 1.53 as my coordinates there. Okay, and a possible solution. That would be 6, 10 or something like that. And I'm not going to check the validity. I'll let you do that. That would be it for 5. And also assign 7. For 7, I will just make the key. And, or should I add it to the video? Maybe I'll add it to the video. So I will do 7 real quick here. 7. It says graph the solution set. So basically graph and determine a solution. And then we will check if each of the following points is a valid solution. So we'll see. So 7a, let's write them out. 9x plus 18y is less than 18. And the other is 3x minus 6y is negative, or less than or equal to 18. So notice that y has a negative in front, so when you rewrite it, you know you're going to have to flip that sign. They're both in the format that I want them to be. So let's just leave it like that. So 9x is equal to 18. Divide both sides by 9, x is equal to 0. Same with the other side, 18y is equal to 18. Divide both sides by 18. Y is equal to 1, 0, 1, right? No problem there. Let's rewrite it. We go less than minus 9x plus 18. Divide everything by 18. Y is less than, that's 1/2, right? You can leave it or change it, it's up to you. You can leave it at -9/18. This one is dashed. The true region is below. The shading is above. Okay, done with that. Next, X-intercept, Y-intercept again. So we have 3x is equal to 18. Divide both sides by 3. X is equal to 6, 6, 0. The other side is -6y is equal to 18. Divide both sides by -6. Y is equal to -3, 0, -3. -6y is less than or equal to -3x plus 18. I'm basing it on this one. Then I need to divide both sides by -6, right? So I need to flip the sign, and this is 1/2 x minus 3. They both have the same slope, so this is going to be an interesting. Could be that there's no solution, okay, because they're parallel. Then we have that this is a solid line. True region is above the line, so we will shade below. Now we're ready for our graph. Quite often it's a good idea to find a point of intersection first, just to make sure that you will have it on your grid. But so we have 1, 2, 3, 4, 5, 6. 1, 2, -5. 1, 2, 3, 4, 5. The y is the x. 1, 2, 3, 4, 5. -5. So we have 2, 0 here, 0, 1 there, and this is a dashed line. And my slope is negative. Actually, they're not the same slope. Sorry, I didn't see that earlier, right? This one is negative. So this is a dashed line like that. Y is less than -1/2 x plus 1. And the other one is 6, 0, way out here, 0, -3. And my slope is positive, so I do expect it to go up. And that one is a solid line. Okay, all right, so this one, let's shade one at a time. So the dashed, we're shading above. And the other one, we're shading below. Okay, solution, POI. So one is -1/2 x plus 1. The other one is 1/2 x minus 3. Should all fit on our screen. Looks about the same. Trace 5, enter, enter, enter. 4, -1. And a possible solution is -2, -1, let's say. And the other points that you have there, again, right, those points you need to plug into each one of these and see they have to both be true for them to be considered part of the solution system. I will work this out, but it will not be on the video. All right, if you made it this far, way to go.